All right, work function is useful for photoelectric effects, so we'll put it all together next time. But work function is psi, again. And it is measured in EVs. It's an energy, so it can be measured in EVs most often. But it can also be measured in joules. And it is the amount of energy it takes to ionize an electron on a piece of metal. So if you think about a piece of metal, like tungsten or some other type of common metal, it has energy levels just like all atoms would have, and it has energy values associated with those levels. So minus 20 EVs, minus 10.5 EVs, minus 5.4 EVs, and so on and so forth. Well, the amount of energy it takes to move this electron, to ionize it, to remove it from the piece of metal or the element completely, is called the ionization energy, but we can also call that the work function of the metal. Find that. Work function of the metal. Basically, the amount of energy needed to ionize or free an electron. So most often it's the energy value associated with the ground state on these things. So the work function of this thing would be 20 electron volts. That's how much energy it takes just to get the electron out of the atom completely. Well, what's left over goes into kinetic energy. So we have energy level diagram. We take an electron and suppose that that thing is at negative 15 EVs. And we bombard it with a photon. Photon comes in here. And suppose that photon has 20 electron volts of energy. Well, the first 15 electron volts of energy are used to ionize the electron. So we started with 20 electron volts from that photon. We've now lost 15 of those electron volts to ionize it. So what we're left over with is 5 electron volts goes into speeding the electron away. So this 5 left over is now the kinetic energy within that electron. And once we have kinetic energy, if you remember, we can use that to calculate velocity of that electron. Mass of the electron is constant, so whatever energy is left over goes into speeding it away. And that electron will leave with 5 electron volts of energy, and then we can use that to solve for velocity. What will we have to do with this 5 electron volts before it goes into there? We need to convert to joules first. So convert the 5 electron volts to joules, and then move on with our old kinematics equations. There's only 2 kinematics equations that work for atomic physics. That's momentum and energy. All the rest of the stuff, the projectile motion things, most of the kinematics equations are eliminated because these are tiny particles that don't really obey Newtonian physics. There's new physics involved, but energy and momentum do stay constant throughout everyday physics and then quantum physics. That's everyday physics too, but not that you see it. So we have an equation that includes work function. And if you kind of logically followed what we were doing here, you'll be able to come up with it. The kinetic energy of the photon, K, let's call it K. The kinetic energy of the electron, rather, that's leaving the element, will be equal to the energy of the photon which came in, 20 electron volts, minus the work function of the metal. So this is the equation to calculate energy. Now you have to be very, very careful here because not all of these pieces are talking about the same thing. This piece is talking about the speed of the electron, or the kinetic energy in the electron. This piece, what was that talking about? What has energy hf? Photon. So this is photon energy. And what is this talking about? The work function of the metal. So it's a little bit of a hairy equation because there's three different pieces that are involved in it. One, the electron, two, the photon, and then three, the metal itself. That's the only equation with work function in it. If you can't use that, then it's got to be logical. But note, these are all energies. Kinetic energy, HF, and work function. So be careful as you're going through the math to make sure that you have the same units on all of those as well. If you use EVs here, you've got to use EVs here, and you've got to use EVs here. And you got to convert when you don't want to use EVs, and vice versa. Okay?